Hello kids, I'm back with another lesson. Welcome to factoring. Why, you ask? Why do I have this list of the first 100 numbers in a grid? Here's why. We're going to learn about something called the prime factorization. You may have heard of this before, but here's a nice refresher on it, and it may be a new visual picture for why it works the way it does. So of all these numbers, what we're going to do is find their factors. We may not do it for every single number because the space required to do that would be enormous, but we're going to do it for the first few and see how it goes. So I'm going to mark a number with the red marker if it is a prime, and then for every number that divides, such that that prime divides the number, I'm going to mark it with the blue marker to show that that prime is a factor. So here's what we're going to do. 1. This isn't a prime, but it doesn't have any prime factors. Prime numbers are the ones that are only divisible by themselves. And 1 unfortunately doesn't make the cut because of a technicality, but we can move on from there. 2. There's nothing that divides 2 besides itself in 1, so we're going to call that a prime. 3. Actually, before we move on to 3, here's what we're going to do for 2. This is the second number, so we'll move forward 2 more. 2 divides it, 2 divides it, 2 divides it. So that means half the numbers going forward are going to be divisible by 2. Meaning everything in this column, everything in the boxes I'm marking with blue are divisible by 2. Since the columns have an even number of rows, or even number of elements in the columns, we're going to go ahead and box up the even ones. What these mean, they just mean that everything in the box is divisible by 2. Two itself is a prime, so it still gets the red check mark even though it's in the box, but of course it is divisible by itself. The next number we get, 3 isn't in any of the 2 boxes. So we're going to check this with a red marker. 3, these aren't all divisible by 3, so we can't just go ahead and mark boxes anymore. But we'll look and say, this one has a 3 on it because 1, 2, 3, 1, 2, 3, 1, 2, 3, that's a 3. 1, 2, 3, 1, 2, 3. You're kind of getting the picture. Every third number is divisible by 3. And from there, we can just get all of these things that I'm underlining are going to get taken out of consideration for being prime. After we've done that, I'm going to pause the underlining right here to save time. I'm sure that you could, on your own, go ahead and mark every third thing. Actually, interestingly enough, if you look at them this way, you can actually box them like this. Because every third thing, this is going to grab enough of them, but only multiples of 3. Since these rows are 10 numbers long, if you go backwards 1 step, you're only moving forward 9 numbers. And since 9 is divisible by 3, then we're okay to do this as well. So I'm actually going to box them this way. I hadn't thought of that until just this moment, but all of the ones in these diagonal boxes are divisible by 3. And then once I've finished this, I'm going to move on to the next prime number and kind of continue the cycle until there's a pattern that shows up. It's a little squiggly for this box, but that's just because the numbers are wide. Now, once we've gotten these done, we're going to be able to look at the next number on our list, which is going to be 5. We don't need to worry about 4 because 4 is already in a box, so we know that it's not prime. We'll continue on from here in a moment. Actually, you know what? There's only a couple lines left to do. I'm just going to go ahead and circle it. I got this. And boom, there's all the multiples of 3 gone. Now if you notice, most of the numbers are in a box at this point of some kind. Half of the numbers are in these boxes, a third of the numbers are in these boxes. Now we've got the numbers that are divisible by 5. 5, of course, is prime because it's not in a box and it's the next number to go. Now since 10 is divisible by 5, there's going to be another opportunity to make one of those boxes that looks really nice and neat. I'm going to do this with the black marker to distinguish it from the boxes that are divisible by 2. So I'm going to go ahead and, even though I mix the markers a little bit, I'm going to go ahead and circle this all the way. And then these are already divisible by 2, but since they're divisible by 10, they're divisible by 5 as well, so I'm going to put those in another 5 box. The next number that we have to worry about is 7. In a moment, we're going to see a pattern emerge with all of this. So I'm going to check that one off because it's prime. I don't think there is such a convenient way to box up the multiples of 7 in this grid, because 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. It just doesn't really come quite so cleanly as it otherwise did with 2, 3, and 5. But what we're going to notice is that the numbers that are in the intersections of these boxes, meaning where the boxes overlap, are divisible by both of them. So for example, 6 is in the box for 2's, and it's in the squiggly box for 3's. So it's divisible by 2 and 3. And, wouldn't you know it, 2 times 3 is 6. Now, if we go over to 10, it's in a box for 2, and it's in a box for 5. So 2 times 5 is 10. You have to be careful with this because there are some times whenever a number would be in its own box twice. Like for example, 4 is in the 2 box and nothing else. So that means no other prime numbers divide 4, but 2 doesn't equal 4. You're going to have to actually use 2 more than once to get there. So 2 times 2 is 4. The important thing to note here is that whenever you have a product like this, it's not always easy to see how many times a prime will divide it. What you'll have to do is move forward from the prime itself times. So like 3, let's do that 3 times. 3, 6, 9. Now we're on 9, and that, every multiple of 9 is going to be a multiple of 3 twice. And so on and so forth. So if you get to 8, you're going to have 3 2's. If you get to 32, you're going to have 5 of them. But let's continue on for a moment. 10, 11. This is also conveniently a prime number. Unlike 7, however, 11 does have a nice little box you can put around the numbers. I'll just go ahead and have to make the marks for the 7 ones. 7, I'll do that with the red marker actually. So watch out, these aren't going to be prime numbers. They're going to have 7's beside them. Just to kind of make sure that we have a clear picture that 7 divides those numbers. There's only a few of these, so we don't have as many things to write down as we did the first time. So 47, I'm at 49. 49, importantly, divides 7 twice because 7 times 7 is 49. So we only have a couple more of these to write, and then we can begin to wrap up here. So there's all the 7's. The 11's can also go into a neat little box, but since there's not as many of them, because 11 is such a bigger number than some of the other primes that we've been using, we're only going to get one box at all with these. But when we've got it, most of the other boxes should come pretty quickly. Since 11 times 11 is larger than 100, we don't need any more boxes. Now, everything else on this list is prime. Everything not in one of these boxes and not marked with a 7 is a prime number, because everything less than 100 is either a prime, meaning it has none of these factors, or one of the primes smaller than 11 has to divide it, because when you get to a prime large enough to where you have to multiply by itself and you can't stay smaller than the biggest number on our list, then everything else has to be prime as well. So we don't even have to check them. 13 is prime, 17, 19, 23, 29. If you see 26, it's a little tricky here because, oh yeah, that one's actually in a 2 box. I was looking at the 3s and thought I dodged it, but yeah, 29, 31, 37, 41, 43, 47. We're getting close here. 53. Let me make sure that's right. Yep. 53. 59. 61. 67. 71. 73. 79. 83. 89. 91 has a multiple of 7 here, so we can't check that off. I'm actually going to circle these multiples of 7 real quick just to finish us off. Just so there's no confusion between the check marks and the things marked with a 7. 84, 91, 8. And then finally, our last prime, the last one not in any of these boxes, is 97. So, by doing this, we can find, by looking at the overlaps here, all of the prime factors, at least the individual prime factors, of every number smaller than 100. And there's not something special about 100 that allows us to do this, which we wouldn't be able to do for any other number, but I just chose this as our example. By doing something like this, this gives us some insight into what the prime numbers look like and what it looks like to factor something into its prime factors. Thank you. Have a good day. And if you want to know more about that, feel free to ask me. I've been doing some personal research on it. So, have a good one, y'all.